Alright, so today, after that first little bit of introduction last time, today we're looking at multiplying and dividing. So first of all, we'll start with multiplication, and we've used techniques before for that, and so we use the same process as we would if you're expanding brackets. So FOIL or whatever pattern it is that you use to do that. So if I want here, turn my pen on, I want Z1 times Z2, and so Z1, which is 3 minus 2i, and I want to multiply that by Z2, which is 1 plus I, then essentially what we've got here is two brackets, so we expand them the same, and the pattern that I use is I go 3 times 1 is 3, 3 times I is 3i, 2 times negative 2i times 1 is negative 2i, and negative 2i times I is negative 2i squared. So here we've got 3. These two middle terms are i's. 3 minus 2 is 1. And then, of course, here I squared is equal to negative 1. So we've got a negative and a negative. So that becomes plus 2, which is then 5 plus I for our final answer. All right, so multiplication, just using that binomial bracket expansion, whatever pattern it is that you use to do that, and collect your like terms. All right, so the next thing we want to look at is what's a definition of something that's called a conjugate. Now, you might remember that we did things with conjugates back when we did surge, when we were rationalising the denominator. So if we borrow that idea, so then for z equals a plus bi, then its conjugate, which is z with the hat, or the bar I should say, z bar, is a minus bi. Now, the thing is, if we, so consider z times z conjugate. So if we do that, you've got a plus bi times a minus bi. All right, and so when we expand that, we've got a times a, which is a squared, a times negative bi, so negative a bi, bi times a, so plus a bi, and b negative times a negative is a negative, that's positive, and times a negative is a negative, b squared, I squared. Of course, I squared is negative 1. So we've got a squared, you got minus abi plus abi, so they cancel each other. That negative and that negative is a plus, so plus b squared. So you'll notice then that now when we've multiplied a complex number by its conjugate, we don't have an imaginary part. So we've now just got a real number and an a squared plus b squared. So the real part squared plus the imaginary part squared. And so what we're going to do is use this idea when we divide complex numbers. All right, so the convention is to express the denominator of a division as a real number, so not as a complex number. So here's an example. Z1 is 2 minus I and Z2 is 3 plus 2i. And we want Z1 over Z2, or Z1 divided by Z2. And that, of course, is 2 minus I over 3 plus 2i. All right, and so we want the bottom as a real number. So what we've got to do is then we've got to times top and bottom by the conjugate of Z2. All right, very technical mathematical terms there, top and bottom, numerator and denominator, of course. All right, so then what that means then is we get a sum that looks like this. We've got 2 minus I and 3 plus 2I. Three minus 2I, we're multiplying by the conjugate, remember? Okay, and so now we just expand those out. So 2 times 3 is 6, 2 times negative 2I is minus 4I, minus I times 3 is minus 3I, minus I times minus 2I, minus times minus is a plus, 2I squared, over, all right, you can expand this out. If you like, you can expand this out, or you can remember this fact up here, all right, that when you multiply a number by its conjugate, you get that, all right, so like if you forget that relationship, that it's the real part squared plus the imaginary part squared, you can just do the multiplication, all right, so you don't need to stress about things like that. Just do the multiplication, which is, to be honest, what I would always do. I'm not good at remembering things like that. To me, personally, I don't see why I need to when I can just do it easily. So 3 3s are 9, minus 6I plus 6I minus 4I squared. All right, so for me, that's just as easy for me to do. All right, so this one here, because it becomes negative 2, because we've got 2 times negative 1. This one here becomes plus 4, because we've got negative 4 times negative 1. And so, what have we got? We've got 6 minus, oops, sorry, 6, what I don't need the 6. What have I got? On the numerator, I've got real part, 6 minus 2 is 4. Imaginary part, minus 4I minus, so that's minus 7I. Over on the denominator, the imaginary parts cancel, and I've got 9 plus 4, which is 13. All right, so 4 minus 7I over 13. And often you'll see it written like this. Not sure whether you'd call that a convention, but you'll often see things written like that with that fraction part taken out. All right, so there's that. Let's have a look at some other examples. So here we've got solve for Z, and here we've got this times this. And so if it's that times that, normally what would we do? We'd divide by 2 plus 3i both sides. All right, so just exactly the same kind of thing as if we were doing, say, 2x is equal to 3. We would divide by 2 both sides. All right, so again, we're using the same techniques that we would do. Now, when we've got this division, now we need to go and think, okay, now we've got this, we need to express my denominator as a real number, not an imaginary, so we multiply top and bottom by the conjugate. All right, and go from there. So negative 1 times 2, negative 1 times negative 3i, negative 2i times 2, negative times a negative is positive 6i squared, which of course is then negative 6. And on the bottom, denominator, we have 2 2s is 4, minus 6i plus 6i, cancel, cancel, minus 9i squared, which of course then becomes plus 9. So, neaten it up, real parts on the top, minus 2 minus 6 is minus 8. 3i minus 4i is minus I. 4 plus 9 is 13 again. Alright, now you might see this written, yes, the 1/13th, but you'll notice that there's a minus there and there, so you might actually see the minus taken out as well. Alright, and that be written as your answer. Okay, so just need to be aware that when you're looking at the answer in the back of the book, sometimes they're a bit lazy in the back of the book. And so they may have it written in a different answer, a different format than what you have. All right, but right, so here we go. All right, so if z equals 2 minus 5i, find z to the minus 1. All right, so from our index laws, anything to the minus 1, a to the minus 1, for example, the minus is 1 over a. Well, the minus is the 1 over, and that's a to the 1, of course. So z to the minus 1 is simply 1 over z, which is 1 over 2 minus 5i. Now, because we've got a complex number on the bottom, we want to express it as a real number on the bottom, so we multiply top and bottom by numerator and denominator by the conjugate. All right, there's the conjugate. All right, because it's just a 1 up here, it's 2 plus 5i. And underneath, 2 2's 4, plus 10i, minus 10i, minus 25i squared, which of course is then plus 25. So you've got 2 plus 5i over 29, which you might write as, I'll give myself enough room, but anyway, equals 1 over 29, and in brackets 2 plus 5i for our answer. All right, so there's multiplication and division. So we're using some of the same processes and things that we've done in the past. We're now just applying those to be able to multiply and divide complex numbers. All right, so as always, have fun.